In the heart of America's military-industrial complex lies a place that few outside highly restricted circles have ever seen. This is the facility where some of the most powerful, precision-engineered weapons in the U.S. arsenal are born. A place where thousands of units of one of the most feared families of ordnance, the GBU series, are meticulously designed, manufactured, and tested. Walking through this facility is like stepping into a world where technology, secrecy, and military necessity converge. It is not just about building bombs. It is about creating systems that redefine what modern warfare means. Systems that balance devastating power with pinpoint accuracy. When people hear about a bomb factory, the first image that comes to mind is a rough, industrial plant churning out crude explosives. But what actually goes on inside is something far more complex. The facility resembles a hybrid between a high-tech laboratory and a massive assembly line. Engineers, technicians, and defense specialists move with precision, working with robotic arms, computer-controlled, machining tools, and advanced testing rigs. The focus here is on the GBU series, a line of guided bomb units that have become synonymous with the United States' ability to strike hard, fast, and with surgical accuracy. The GBU family has many variants, from the bunker-busting GBU-28 to the GPS-guided GBU-31 JDAM, and even the smaller, lightweight precision bombs like the GBU-39. Small diameter bomb. What makes them so intimidating is not just the raw explosive power packed inside their casings, but the way they are designed to find, lock onto, and destroy targets with extreme precision. For decades, warfare was dominated by the sheer destructive radius of unguided bombs. But here, in this restricted facility, the philosophy is different. Instead of leveling entire city blocks to hit a single target, the design principle is to neutralize specific objectives with minimal collateral damage. Walking through one of the production lines, you immediately notice the emphasis on modularity. Each GBU is not built as a single, unchangeable bomb. Rather, it is a system, a combination of a warhead, a guidance kit, and in many cases, a propulsion system. The warhead itself might be a conventional high-explosive casing or a specialized penetrator designed to cut through concrete bunkers. The guidance section could be laser-based, GP, S8ED, or even a hybrid of multiple systems. This modular design allows the U.S. Air Force and Navy to adapt quickly to different battlefield requirements. If intelligence comes in about a target hidden beneath hardened shelters, engineers can swap in a penetrator warhead. If a moving target needs to be hit in an urban environment, a precision guidance system ensures that the ordnance strikes within a meter of the intended point. One of the most fascinating aspects of these weapons is the balance between old-fashioned brute force and cutting-edge digital engineering. Take the GBU-43, often called the mother of all bombs. It is one of the largest conventional bombs in the U.S. arsenal, weighing over 21,000 pounds. Its sheer size alone makes it terrifying, but what makes it particularly frightening is that it combines enormous destructive capacity with GPS guidance, allowing it to be delivered with remarkable accuracy. Inside the facility, the components of such massive weapons are carefully manufactured and assembled under strict protocols. Each part is cataloged, inspected, and tested multiple times before it becomes part of a finished unit. The smaller GBS, such as the GBU-39 small diameter bomb, represent the other end of the spectrum. Unlike the MOAB, which is designed for maximum destruction, the SDB is built to be compact, efficient, and precise. It weighs about 250 pounds, which is tiny compared to traditional 2,000-pound bombs. But its ability to glide over long distances and strike with surgical accuracy makes it highly effective. For aircraft, carrying multiple SDBs means they can engage more targets in a single sortie without compromising on range or maneuverability. In the restricted facility, you can see how these bombs are produced in much larger numbers. With assembly lines designed to turn out thousands of units to maintain U.S. air power superiority, the performance aspects of these GBRs come down to guidance, delivery, flexibility, and adaptability. Older bombs relied heavily on laser guidance, which meant that a target had to be illuminated by either ground troops or an aircraft. While effective, this left room for weather, interference, or obstacles blocking the laser. The introduction of GPS-aided guidance changed everything. Now, these bombs can be dropped in all weather conditions, day or night, and still reach their intended targets. Inside the facility, racks of guidance kits wait to be fitted onto warheads. These kits are essentially the brains of the bomb, containing sensors, processors, and control fins. Once attached, a simple unguided bomb transforms into a precision weapon capable of being steered to within a few feet of a target. Another key design element is survivability. These bombs are not just designed to explode on impact. They are engineered to survive the stresses of being dropped at supersonic speeds, from high altitudes, and sometimes even released from stealth aircraft, where space constraints demand compactness. The casings are forged from specialized alloys, designed to withstand intense pressure and temperature changes. Each weld, bolt, and seam is inspected using advanced scanning technology to ensure there are no weaknesses that could cause failure during deployment. The margin for error here is virtually zero. A single defect could compromise a mission or worse, put the aircraft and its crew at risk. What makes these weapons uniquely powerful from a strategic standpoint is how they integrate into the larger U.S. military framework. It is not just about dropping bombs, it is about combining real-time intelligence, satellite targeting, and advanced aircraft systems. A GBU is never acting alone. When a pilot releases one, it is often the result of layers of reconnaissance, satellite imagery, and digital command and controlled systems. This fusion of intelligence and precision engineering ensures that each bomb dropped is not just an act of destruction, but a calculated move within a broader operational plan. Inside the restricted facility, another remarkable sight is the testing chambers. These are not the dramatic live-fire explosions you see in military videos, but controlled environments where engineers test guidance systems, aerodynamic stability, and even the durability of bomb casings. High-speed cameras, wind tunnels, and vibration rigs simulate the stresses of combat conditions. A GBU that passes these tests is not just considered functional, it is certified as battle-ready. The level of scrutiny is so intense that even tiny variations in aerodynamic performance are logged and This is what sets the facility apart from ordinary weapons plants. Here, perfection is not a luxury. It is the standard. One of the most talked about unique selling points of the GBU series is its ability to minimize collateral damage while maximizing mission success. This may sound like a paradox, but it is achieved through the precision of the guidance systems and the careful calibration of warhead yields. For example, a GBU-39 small-diameter bomb can strike a target buried deep within an urban area without causing widespread destruction to surrounding structures. This capability is critical in modern warfare, where targets are often hidden among civilian populations. Inside the facility, engineers spend a considerable amount of time working on fusing mechanisms, which control the timing and manner of detonation. By adjusting these mechanisms, the bomb can be made to explode after penetrating several layers of concrete or to detonate instantly upon impact, depending on the mission requirements. Perhaps what is most chilling about this restricted facility is the sheer scale of production. Thousands of these weapons are built, stored, and shipped to bases around the world. The production pace reflects not only the current operational demands, but also the preparation for future conflicts. It is not just about having enough bombs for today's battles, but about maintaining a stockpile that ensures military dominance for years to come. This massive output is carefully tracked using digital inventory systems. Every single unit is tagged, logged, and monitored from the moment it leaves the assembly line until it is eventually deployed. The secrecy surrounding this facility adds another layer of mystique. Workers undergo intense background checks, and entry is strictly controlled. Even among employees, access is compartmentalized so that individuals only know what they need to perform their tasks. Cameras are prohibited in most areas, and digital systems are hardened against cyber intrusions. For outsiders, it is nearly impossible to gain insight into the day-to-day operations here, which is why so much of what happens inside remains shrouded in mystery. Yet the existence of such a facility underscores the reality of modern warfare. Precision-guided munitions like the GBU series are not just tools of destruction. They are instruments of strategy, leverage, and deterrence. They send a message to adversaries that the U.S. military has the capability to strike anywhere, anytime, with devastating accuracy. At the same time, they serve as a reminder that behind every mission, there are teams of scientists, engineers,